So we know that in 2 dimensions, a circle is a shape that consists of ever so many triangles. But let's take a look at that shape, boundless, in the 3rd dimension. The acceleration due to gravity is absent here on the ISS, and astronaut Scott Kelly is taking advantage. As you see, a circle is a natural shape for a mass not being acted on by exo forces. But let's pan to a much larger mass, our Sun. Our Sun is also not bound by exo forces, but rather bounds others into it using gravity. The circle, or sphere, is nature's carving stone of a shape. Now, gravity on Earth, always creating parabolas as we're seeing right here, up and back down. The parabolic force that bounds us here on our spherical planet of the ever billions of spheres in this universe. Here, on our tiny dot, we get to call home. Now let's manipulate this parabolic force of gravity. NASA has launched a space probe, Juno, and it's using gravity slingshotting to save fuel and get to its destination faster. Juno was launched in 2011 and is aimed towards Jupiter. As seen in this demonstration, Juno is using Earth's gravitational pull to slingshot its way to Mars. And from Mars, it'll slingshot its way to Jupiter. Juno is on its way to Jupiter to study its atmosphere, its different ammonia molecules. After getting its data, Juno will then slingshot itself away from Jupiter to safely send home data. And for the good stuff, we have ellipses. As we know, planetary orbits are elliptical. This has to do when the solar system of the planet was formed, and the speed along with the distance of the planet or any other celestial body that may be orbiting the host star. We know Jupiter's orbit takes much longer due to its distance from the Sun and its initial velocity when entering the solar system. This applies to every body in the solar system. See, the Sun has a curvature in the space-time fabric and causes bodies to follow it and take its elliptical path, the same way a well would do to a coin. Now, as we look at Saturn's moons, we see the same elliptical orbits. Elliptical orbits will follow us anywhere through the cosmos, through moons, planets, rings, comets, stars, and even possibly galaxies. Gravity acts parabolic, elliptical, and in absence, spherical. Remember, these big equations and discoveries were founded by men who wandered and looked up. Thanks to them, we wander, look up, and do.